Okay, in this program, we are going to create a recursive algorithm that will sum some numbers together. So, like, create a total of those numbers. So this is how it's going to work. We're going to need. We don't need this. It just cleans it up a little bit. We're going to have a result value in the main program that's going to just store the sum so that we can print it. So we're going to have the result become the sum, and then I'll explain how this method is going to work here. And then we'll print out the results. So system.out.println the result. The way this is going to work, we could just simply print out the sum. This just cleans it up for me. So what we're going to do is this will sum the numbers from 1 to 5. So this is something that you would probably use like a for loop for usually, but we're going to create a recursive way of solving this. So we need a new method here. So this is going to be public static int sum, and we're going to get int n here. Okay. So how are we going to do this? Let's say what the method is doing. Usually a really good idea at the beginning of the method, say what it's doing. So this will sum the numbers from 1 to n. Now, the advantage that we're going to take here is that it really doesn't matter what order we add these numbers together as long as we get all of them added up. So like our count up example, where the recursion just naturally kind of wants to count down, we'll let it kind of do its thing. So the way this is going to look is our function of n is going to be n plus n minus 1 plus, we'll get a bunch of numbers in here, plus 3 plus 2 plus 1, and then it will be finished. So using the pattern from our counting programs, we can see that we can create a recursive statement for this, f of n, and in this situation, it will be like taking n plus the function of n minus 1, which of course will go, n. The result of this would be n minus 1 plus the function of n minus 2, and so on and so on and so on. How are we going to do this? The first thing that we're going to start with is our base case. So the base case here is if n equals 1, we have reached our last number. What we're going to do is we are going to return 1. That's it. So this is going to be the end situation. F of 1 is going to return 1 because, like, imagine you were just creating a sum of just the value 1. It would be just 1. Now, what is our recursive case? So for this, we're just simply going to have a return statement. So we're going to return the value of n plus the sum of n minus 1. And that's actually the entire solution. So sometimes when you're writing these recursive programs, they're tiny. This is even just seems small compared to like a loop to solve this. So if I'm running the program, we get our value of 15, which is the numbers 1 to 5 summed together. So I can do, 10 if I wanted, although, well, let's make sure my comment still makes sense. And we get the number 55, which is the sum of the numbers from 1 to 10. We can also do the same thing here if we wanted to do a factorial. So if we wanted our result to be equal to, let's say, factorial, let's not go 10, let's go 5, because these numbers get quite large very quickly. And then I'll print it again. There we go. And then let's write a recursive function that'll handle writing the factorial. So I'm going to do a little copy paste because these are such similar solutions here. So this one is going to be factorial. Now, the way we write this is factorial of the number n, which is the same way as writing n exclamation point. So if we're doing that, say 5 exclamation point, so 5 factorial is 5 times 4 times 3 times 2 times 1. And of course, this is used a ton in combinatorics, where you're trying to sort of find different combinations of different items. It's used a whole bunch. So this is pretty important. Now, in this case, f of n would be n times, and then we just have to multiply these things instead. And then we want to go all the way to 1. So I could make a case for like why this would be a lot more useful than this. And then all we have to do for this is we have to change this to be n times factorial n minus 1. So now if we run this and get the factorial of 5 here as well, it'll be the second number. We'll get 120. So anyway, this is sort of like a little bit more like an accumulator type loop thing, running with recursion. But this one here is actually useful. So as we move through this, you can create some like really small bits of code that do an awful lot very quickly.